Look around you and you'll see natural energy. Harness it and make it work for us. We could be on the way to realising a dream for the future. Waves, wind and sun won't run out. Use them to provide energy and it will be renewable. We could keep using them. Unlike the fossil fuels such as coal, gas and oil. Fossil fuels like this coal were created millions of years ago, but they will run out because we're using them at a much greater rate than they're produced. We live in a world hungry for fuel, and the demand continues to grow. But for the people in the southwest of England, that dream of an unlimited supply of energy stands a chance of becoming a reality. Candy Stevens works for the Electricity Board in the southwest of England, and it's been studying how much of the region's electricity could be produced by using renewable resources. So what did the study show?
The study actually showed that SWEB could produce between 6 to 12% of their electricity requirement from renewable energy resources by the year 2000.
An electric fire uses electricity. Energy which is transferred electrically is measured in kilowatt hours. That is the amount of energy used by a 1 kilowatt bar fire in 1 hour. The South West Electricity Board has also been looking into how farming can help in the production of renewable energy.
The South West is heavily dependent on the rural infrastructure, the farms that provide the food for the cities that have created the growth in this country. But farmers are now almost victim of their own success. So this now means that farmers are having to look at alternative uses of their land, which we view as a very exciting step forward in the production of renewable energy sources.
These alternative uses for the land come about because Britain grows more food than it needs, producing a surplus. To counteract this, farmers are sometimes encouraged to set aside some of their fields and let them lie fallow. This field of wheat is about to be harvested for the last time. And in its place, poplars. Trees. This farm is experimenting with growing trees as a crop to produce not food, but fuel for power stations.
I think what really set me off here was the set-aside nonsense, you know, where farmers are paid for really doing nothing and just leaving land fallow. And I thought there must be some better way of dealing with this set-aside problem than that. And this seemed to be one answer, you know, to grow a fuel crop and to see which would grow best on these conditions. One of our main enterprises on the farm is a glasshouse industry. That is heated with oil at the moment. Oil is expensive, it's polluting, because it's got a lot of sulfur in it. And in a couple of years' time, the heaters will be worn out, so they'll be due for replacing. And that, I think, will be an ideal time to switch to using the fuel that we're producing on the farm, the wood chips, to heat the glass houses. Maybe also the farmhouse as well. So, I mean, we've got an on-farm use for the product, really.
This means that Ray's farm will have switched from using oil, non-renewable, to wood chippings, a renewable fuel. John Hurl is the head forester on another estate which has switched from growing wheat to trees. But why?
With all the EC surpluses at the moment, the estate was looking for an alternative crop to wheat for some of the fields on the estate, and we've plumped at the moment for poplar in this field because it's drier, and on the wetter sites willows, to produce, we hope, a new crop which will be a wood chipped crop which will actually be sold for energy to the power producers.
How do you plant them?
On normal trees you would have a rooted transplant which you would actually have to put in the ground. You have to buy from a specialised nursery. With the poplars, they're actually just a cutting which is about 25 centimetres long and can literally be made from a rod and this is literally just pushed into the ground and left.
And that's it, it grows?
And that's it, it grows. When it's on its first year, it's just a single stem, and to produce the coppice effect, we have to cut it back, and then we get a multi-stemmed plant shoot up.
How many years before you can harvest it?
After the cut back, it's 3 years. It will be harvested with virtually standard agricultural machinery. It will be a forage harvester with a modified head on it, and just a silage trailer going along beside collecting the wood chips. We're hoping that it will actually produce 10 to 12 dry tons per hectare per annum.
That's a lot of wood chippings by anybody's standards, but the same amount of energy will be produced by only half the amount of coal. Wood chippings are much bulkier and so more costly to transport to a power station.
It's where we're currently developing the UK's first wood-fuelled power station at Indian Queens here in Cornwall. The proposed plant is to be about 2.5 megawatts, which is equivalent for the electricity generation for about 5,000 homes. And we'd look to use arable coppicing, such as this, for that fuel supply. What we'd actually look to do is take in wood chip into the plant, burn it through a combustion unit and generate electricity.
There's an important environmental effect in the burning of these trees too. During its life, a tree takes in minerals from the soil and carbon dioxide through its leaves. If the tree is then burnt, only the amount of carbon locked up in the plant is released into the atmosphere as carbon dioxide. So for a 3-year-old tree, this carbon dioxide cycle is quite short. But this cycle is much longer in the case of fossil fuels, such as coal. They were formed from plants millions of years ago, and when they're burnt in power stations today, the huge amount of carbon dioxide released adds significantly to global warming. The trees use energy from sunlight to grow, making more plant tissue as the tree gets bigger. The tree canopy works as a solar collector, with each leaf being a very effective solar cell. The leaf takes in carbon dioxide through pores on the underside of the leaf. The carbon dioxide then combines with water in cells nearer the top of the leaf, where the sunlight is absorbed. This energy from the sun enables the reaction called photosynthesis to take place, which then produces carbohydrates and adds to the plant tissue, the biomass. Coppicing is successful because so much of this can be cropped. Here on the banks of the River Tamar, these ancient woodlands have been used to grow wood for fuel for hundreds of years. Elizabeth Hamilton has been looking into the history.
From the records that I've looked at, from 1700 until into the 1800s, areas of coppice woodland, such as this area here, was sold at public auction to local woodmen. In Devon, there are still written records describing how the woodland was managed, dating back to the time of Mary Tudor, 1557. Well, they really used everything that came out of the woodland on a very regular basis. Pieces of wood were used as fuel because certainly until 1830, wood was the primary source of fuel for heating houses and so on.
This was the system that became known as coppicing. Young trees were cut back and the wood gathered, leaving the remaining stump to grow up. After a few years, the trees were cut back again, the wood gathered and the stump left to grow. Huge areas of the countryside were coppiced to provide wood for fuel and other uses. The coppice wood provided fuel for cooking, as well as helping the local gypsy carry out the traditional craft of making pegs, using a design that's lasted for over 100 years. But actually, this peg isn't from the 1860s. We're at a museum in Morwellham in Devon. Gary, what sort of things does your museum show?
Well, the place is a port with a history of well over 1,000 years, but it came to its peak of development in the 1860s. And so we're in the process of recreating the past as it probably was at that time. And of course, at that time, the wood around here was cut. Oak, hazel, all sorts of wood were cut, and they were used for all sorts of things. Every wood can be used for energy. When it's burned, it will release that energy. But oak also could be used for making ships, or it could be used for making casks, barrels. And it was essential, of course, to steam those casks over a fire to shape them.
Today in the Tavistock woodlands, the trees are not coppice, but left to grow to their full height. Tim Timmis is the forest manager.
Greenery of the place, yeah. Different types of conifer.
If coppicing has been so wonderful throughout all these ages, why suddenly stop?
Well, we have the problem of commercial viability and the cost of the labour market, because the whole purpose of coppice here was to support the mining and the leather industries with those products used for tanning leather, creating heat for driving steam engines and for furnacing lime kilns, and also for producing arsenic. And unless you've got a marketplace for that type of material, then people stop working the woods. And for that reason, coppice in this area actually came to a grinding halt.
All of these trees that we've spoken about so far are broadleafs, aren't they?
Yes.
The deciduous trees. Where have all these conifers come from?
Well, with the realisation that the oak woods were no longer going to have a commercial end product, the landowners started looking around for other ways of making a return from this very steep ground. And at the same time as this was going on, we were importing a lot of wood from overseas, from the west coast of America, from Scandinavia. And it made sense, therefore, if those timbers were valuable in commercial terms, to start planting those types of trees. And as a result of that, we have these young Douglas fir that are actually growing up under the oak here. And we've got the Scots pine, which have actually invaded the oak at some stage from plantations adjacent to these oak plantations that were planted purely to actually produce a commercial return of conifers that would produce timber that would be used in industry. The woods produce a natural resource that we can keep turning over. And we're producing a wide range of different products from the woods. We're producing fuel wood at one end of the scale, and we're producing building timbers and structural timbers at the other end of the scale.
Unlike forestry, coppice can be produced quickly, but the traditional methods use a lot of people's time. Nowadays, this is expensive. However, the new arable coppicing on flatter land can be mechanised, which makes it a lot cheaper, although the principle is still the same.
Well, I'm very optimistic about it because it's environmentally friendly. It solves the problem of set aside, you know, for farmers who are not sure what to do with their surplus land. I think the public will be very much in favour of this sort of land use. I mean, it looks attractive. It's very good for wildlife and game. I mean, I've been amazed at the amount of insects in this, and this has only been going 2 years. And wildlife generally. You know, it's lovely walking through here, and I think the public are going to be really behind this development, so I see a great future for it, and I'm very enthusiastic, really.
So it really is a good way of using the energy from the sun?
Absolutely, yes.
What's exciting about the potential resource in the Sweb area is that we don't just have to look at the land. We can look at what's available at the, you know, on the sea or offshore. And this is in the form of offshore wind energy from the strong southwesterlies that roll in from the Atlantic, the wave power and the tidal ranges that exist in the Bristol Channel.
This huge wave, the Severn Bore, happens when the high tide surges up the estuary into the narrower river, causing a bottleneck effect, a potential source of energy that has interested scientists for some time. The idea is that a barrage could be built across the Severn estuary, so that as the sea level falls at low tide, the barrage holds back water. This water can then be released to drive turbines and so generate electricity. If tidal power from every estuary in the southwest could be harnessed, it would be technically possible to produce nearly 17,000 million kilowatt hours of electricity every year. But stopping the flow of a river would affect fish and wildlife, so there are environmental problems to be overcome.
Other resources in the southwest region are as wide-ranging as biogas, which is from human sewage, and we have a very large biogas installation near Bristol. Now these obviously need to be sited near large cities or centres of human population. Other sites would be landfill gas sites where the waste decomposes, a potent greenhouse gas called methane is released, and we can then harness that by burning it and turning that into electricity. We're also able to incinerate waste, and it may well be in a few years' time, Exeter will be burning its waste and producing electricity from the waste of this city.
Small, fast-flowing rivers like the Tamar offer another way of catching energy. Water wheels that have paddles shaped like spoons turn to generate electricity. This is small-scale hydroelectric power. Because of the height of the river, the water has potential energy. As the water falls down, this potential energy is changed into kinetic energy, and this makes the wheel turn. Inside the power station, I could see this transfer of energy in action. These casings contain larger versions of those same water wheels, which are named after their inventor, Lester A. Pelton. They're efficient, with almost 95% of the potential energy being transferred to kinetic energy. Another alternative source of energy is wind power. There are already 4 operating wind farms in the southwest, and wind power offers huge possibilities. Fully developed, wind power alone would be capable of producing over 4 times the electricity currently needed in the southwest. Geothermal energy is another renewable source of energy. The Earth is hotter at its centre, so by drilling deeply, energy can be taken from the hotter rocks beneath. This usually comes out as hot water or steam, which can be used directly as heat or to generate electricity. As long as the sun shines, its energy can be collected. The sun's rays can be directed onto photocells, where the solar energy is converted into electricity. Or we can use the energy in the sun's rays to heat water, so changing solar energy into heat energy. So the future looks good, but it needs to, because despite efforts at conservation, our demand for energy still continues to grow. And if we persist in our use of coal, gas and oil, the non-renewable fossil fuels, they will run out. Renewables, the sun, water and wind power, are natural sources of energy that will not run out, and which could also provide energy in other ways. So it's an exciting future, but one that needs commitment. This future needs to be worked for, now. Look around you and you'll see natural energy. Harness it and make it work for us. We could be on the way to realising a dream for the future. Waves, wind and sun won't run out. Use them to provide energy and it will be renewable. We could keep using them. And like how much of the region's electricity could be produced by using renewable resources. So what did the study show?
The study actually showed that SWEB could produce between 6 to 12% of their electricity requirement from renewable energy resources by the year 2000.
An electric fire uses electricity. Energy which is transferred electrically is measured in kilowatt hours. That is the amount of energy used by a 1 kilowatt bar fire in 1 hour. The South West Electricity Board has also been looking into how farming can help in the production of renewable energy.
The South West is heavily dependent on the rural infrastructure.
Trees? This farm is experimenting with growing trees as a crop to produce not food but fuel for power stations.
I think what really set me off here was the set-aside nonsense, you know, where farmers are paid for really doing nothing and just leaving land fallow. And I thought there must be some better way of dealing with this set-aside problem than that. And this seemed to be one answer, you know, to grow a fuel crop and to see which would grow best on these conditions. One of our main enterprises on the farm is a glasshouse industry. That is heated with oil at the moment. Oil is expensive.
The farms that provide the food for the cities that have created the growth in this country. But farmers are now almost victim of their own success. So this now means that farmers are having to look at alternative uses of their land, which we view as a very exciting step forward in the production of renewable energy sources.
These alternative uses for the land come about because Britain grows more food than it needs, producing a surplus. To counteract this, farmers are sometimes encouraged to set aside some of their fields and let them lie fallow. This field of wheat is about to be harvested for the last time, and in its place, poplars. Fossil fuels such as coal, gas and oil. Fossil fuels like this coal were created millions of years ago, but they will run out because we're using them at a much greater rate than they're produced. We live in a world hungry for fuel, and the demand continues to grow. But for the people in the southwest of England, that dream of an unlimited supply of energy stands a chance of becoming a reality. Candy Stevens works for the Electricity Board in the southwest of England and has been studying